How are similar triangles' altitudes, medians, and bisectors proportional? Imagine you have two triangles that look the same but are different sizes. Have you ever wondered how parts inside those triangles relate? Well, it all comes down to proportionality. When two triangles are similar, their sides match up in a specific ratio called the scale factor. This ratio isn't just about the sides. It also applies to special segments inside the triangles, like altitudes, medians, and angle bisectors. Let's break it down. First, similar triangles are triangles that have the same shape but may differ in size. Their corresponding angles are equal, and their sides are proportional. That means if one side is twice as long in one triangle, the matching side in the other triangle is also twice as long. This proportionality is the key to understanding how other segments inside the triangles relate. Now, consider an altitude. That's the line segment from a vertex straight down to the opposite side, forming a right angle. In similar triangles, the ratio of an altitude in one triangle to the corresponding altitude in the other equals the ratio of their matching sides. So, if one triangle is scaled up by a factor of 3, the altitudes inside it are also 3 times longer. Next, think about medians. These are lines from a vertex to the midpoint of the opposite side. Like altitudes, medians in similar triangles follow the same proportional rule. If the sides are scaled by a certain factor, the medians are scaled by the same amount. So, a median in a larger triangle will be proportionally longer than in a smaller one, based on the scale factor. Then, there are angle bisectors. These are lines that cut an angle into two equal parts and meet the opposite side. The lengths of the angle bisectors in similar triangles also follow the same ratio as the sides. If one triangle is scaled up, the angle bisectors grow proportionally. In fact, if triangle ABC is similar to triangle DEF, then the ratio of any altitude, median, or angle bisector in triangle ABC to the corresponding segment in triangle DEF is equal to the ratio of their corresponding sides. This means that knowing the scale factor allows you to find any missing segment just by multiplying or dividing. This idea is super useful in real life. For example, if you have a small model of a building and know the measurements, you can figure out the actual size by applying the same ratios. Or if you're designing something and want to keep proportions consistent, understanding this proportionality makes it easier. So, in summary, the altitudes, medians, and bisectors inside similar triangles are all proportional to the sides. This consistent relationship makes it easier to solve many geometry problems, especially when working with scaled figures. Remember, whenever you see similar triangles, think about the scale factor and how it applies to all the segments inside.